Hello and welcome back to another Walking Talking mock. We are doing C3 MEI January 2006, so this is Old Spec A2 Maths. And this is section B, we're on question 7. So we have this curve, and the curve crosses the x-axis at A and has a turning point at B, and the point C has x-coordinate 1. C, D and BE are drawn parallel to the y-axis. Okay. Find the x-coordinate of A, giving your answer in terms of E. Okay, so let's write down the equation. Y equals 2x minus x log x. Oh, that's quite familiar. X minus log x. X minus x log x. Is that like the integral of something that we can't integrate? That's the integral of log, isn't it? Whatever. X coordinate of A. So what was A again? A was where it cuts the x-axis. Okay, so I want this to equal 0. Okay, so I'll factorise the x out of that. So obviously x equals 0 is the solution, but that's that point there. So what I actually want is 2 minus log x equals 0. So log x equals 2. So x equals e to the power of 2. Giving your answer in terms of e. Yep, that's fine. Okay. Part 2. Find the find the exact coordinates of B. B was the turning point, so I need to differentiate. Oh, this has got a product. It's got a product rule thingy in it. So, okay. I'll do that bit separately. Let's say, I don't want to call it y, let's call it a different y. Let's call it capital Y, there we go. X log x. Let u equal x, v equal log x. Du by dx is 1, dv by dx is 1 over x. And then dy by dx equals v du by dx plus u dv by dx. That was a close call. Okay. Okay, so now I know that dy by dx is going to be 2 minus log x minus 1, which is 1 minus log x. I'm surprised this isn't like a show that question. I feel like they would give us the answer normally. Okay, but the turning point then, we need that to equal 0. So log x equals 1, so x equals e to the power of 1, or just e. So the coordinates, I need the y coordinate, 2e minus e log e. Log of e is 1. E to the power of something equals e. Yeah, it's 1. Okay, so that's 2e minus e, which is e. So that's EE. EE. Okay. Interesting. What's next? Show that the tangents A and C, where's A and C? Tangents at A and C are perpendicular to each other. Okay. So we know the x-coordinate of A. Oh, and we know the x-coordinate of C because it tells us there. Okay, so at A, dy by dx will equal, what was it? It was e squared. E squared. So that's 1 minus log of e squared. Log of e squared, e to the power of something equals e squared. Okay, the answer to that is 2. That's 2. 1 minus 2, which is minus 1. And at C, we're told the x-coordinate is 1, so 1 minus log of 1. Log of 1 is 0, because e to the power of something equals 1. The answer is 0, so that's 1. So we've got minus 1 and 1. Negative reciprocal, therefore perpendicular. Okay, so we've shown they're perpendicular. Now we're going to have a tricky integration. Well, the integration won't be tricky. The tricky part will be they're going to ask us to find some weird area, I think. Using integration by parts, show that, hence find the exact area of the region. Okay, let's read that bit later. Let's just do the integration. So it's integral of x log x dx. Integration by parts. Okay. So I need a u and I need a dv by dx. I wrote those too close together. Oh well. Which one should I integrate? Which one should I differentiate? Okay. Well, I don't know how to integrate log, do I? So I have to make that the one that I differentiate. Okay. Well, when I say I don't know how to integrate log, you need to use integration by parts anyway, because you have to turn it into like a 1 times log x. So, yeah, it wouldn't be helpful. Du by dx equals a 1 over x, and v equals half of x squared. So let's bracket that off so I can say equals uv minus integral of v du by dx. That x is going to cancel, so it's just be x over 2. Like that. Okay, which is alright, because I know how to integrate that. I just need to raise the power and divide by the power. Stick a plus c on there. And that was the answer that they gave us. So that's fine. Hence, find the exact area of the region. Let's work out what region they want. Enclosed by the curve, the x-axis, and the lines C, D, and BE. Okay, so basically they want this bit. That doesn't seem too bad. I just need to put limits on it. D, what was the x-coordinate of D? Oh, it's the same as x-coordinate of C, obviously. And that was 1, wasn't it? And then the x-coordinate of B was E. So I just need to integrate between 1 and E. That is fine. So I just need to take that and put area equals between 1 and E. So E squared over 2 log E minus E squared over 4 minus half log 1 minus a quarter. Log of E is 1, because e to the power of something equals e. That would have to be 1. So we've got e squared over 2 minus e squared over 4. Log of 1 is 0, because e to the power of something to make 1 would have to be 0. And then I've got a plus quarter. That, take away that, a half take away a quarter is a quarter. So that would be that. It's an area, so I'm going to write units squared. Cool. Let's check the mark scheme. Oh, I got the wrong answer. Wait, what did I do wrong? Oh, I'm so stupid. This integral isn't this integral. Look, they only did the x log x bit. They didn't do the 2x minus bit. So I'm so sorry. So I need to, should we just do this again? Because I also need to integrate the 2x bit. Obviously, if I integrate 2x, I get just x squared. So I just have to squeeze in an x squared. And then the rest, the rest of the integral, it was minus. It's minus. So I just have to minus the rest of this thing. Like that. Read the question carefully, guys. My excuse is like, I'm filming this, so I'm under pressure. Yeah. Okay. Let's see if this works now. So I've got a whole, take away a half, is a half, plus a quarter is 3/4, minus 5/4. Okay, that's the correct answer. Good. Where's the rest of the question? Oh, it's here. Let's mark it. So, we get M1 for equating to 0. We get A1 for the answer. We get M1 for using the product rule. We get B1 for knowing this. We get A1 for 1 minus log x. We get M1 for equaling it to 0. We get A1 for the x, and we get A1 for the y. No, sorry, we get B1. We get B1 for the y. And the B1 is follow through, so if your x was wrong, they'll still let you have the mark for the y. Part 3, we get M1 for substituting one of them in, and you get A1 for both of the answers, and E1 for your little explanation. And then M1 for using integration by parts, so I guess for that bit. A1 for this line here. E1 for the answer since it was given, B1 for making the correct integral and limits. Okay, mine was implied. And B1 for this line as well. M1 for substituting the limits. And A1 for the correct answer. And it is a correct answer only mark there. So, not allowed any kind of following through. Last question. Focus. The function f of x equals that has this domain, and we've got a picture of it. Find f inverse of x, and then hence sketch the graph of it. Wait. Hence sketch the graph of f of x. That is f of x. Oh, for the complete domain. Interesting. What is it? F of x. Oh, did I say inverse of x? No, it's f of minus x. That makes sense now. So f inverse of x is probably going to turn out to be even or odd, and then you know that the other side's going to be the same or upside down. So let's put a negative in here. Now, something you really need to know off by heart is that sine is odd and cos is even, because that makes these things really easy. Because I know that sine is odd, which means that this negative can move outside. And cos is even, which means that the negative can just disappear. And I'll just write that just in case they're suspicious of my intentions. How does that relate to that? It's not the negative of it. Yes, it is. Just kidding. For a minute I thought that like the top and the bottom had to be negated. And then I remembered that if I negated the top and the bottom of the fraction, I've actually not done anything because it's cancelled itself out. So yeah, when you negate a fraction, you only negate either the top or the bottom, not both. So that equals negative f of x, therefore it's odd. It didn't ask me to say whether it was odd or not, but the fact that it's odd means that the rest of the graph, because this only shows up to 0, but it should go up to minus pi, so the rest of the graph is going to be like that because it's rotational symmetry. So it looks like that. And if your drawing is really bad, then write a little note to the examiner, rotational symmetry order 2. Just so they know what you intended to do, because you know not all of us can draw things very well. You just really want to show them that you had the right intentions. Okay, oh, I should also label that minus pi. Yeah, just to show. Okay, what's next? Show that f dashed of x is this, hence find the exact coordinates of the turning point and state the range of the function. Okay, let's differentiate. So f of x equals sine x over 2 minus cos x. So this is a quotient, so I'm going to use the quotient rule. U equals sine x, v equals 2 minus cos x. Du by dx equals cos x. And dv by dx equals, differentiate cos, you get minus sine. So differentiate minus cos, you get positive sine. Okay, so f dashed of x is going to equal v du by dx 2 cos x minus cos squared x minus u dv by dx all divided by v squared, which I don't think I will expand at the moment. Oh yeah, I'm not going to expand it because in their answer they haven't expanded it. But I am going to simplify this because I've noticed a cos squared and a sine squared. And I know cos squared plus sine squared equals 1. So I could actually write this as 2 cos x minus cos squared x plus sine squared x. Like that, if I put that in a bracket. I'm running out of space. Let's go across. That equals 1, so that's 2 cos x minus 1 over 2 minus cos x squared. Which was what they wanted. Then it also says, hence find the exact coordinates of the turning point P. And I'm just going to be a savage and do it here. At P, I need this to equal 0. For this fraction to equal 0, the numerator must equal 0. The denominator is completely irrelevant because there's no way that the denominator could make the fraction equal 0. So that equals 0. Whoops, I missed out my x. Cos x equals a half. So x is the inverse cos of a half, which could be any number of things, but I can see from the picture that it's the principal value. If this kept going, we'd have all sorts of other answers. So x is pi over 3, which your calculator will tell you if you don't know. Yes. Wait. Coordinates. I need the y as well. You know what? I'm doing it up here. Y equals sine of pi over 3. So I'm substituting this into the original f of x. To get the y coordinate, sine of pi over 3 is root 3 over 2. Cos of pi over 3 is a half. And you know what, I'd probably just shove that in the calculator because... Or not. I can do this. 2 take away a half is 1.5. Equals root 3 over 3. So the answer is P is pi over 3, root 3 over 3. Please don't lay your working out like this ever. I'm just, I'm doing it for YouTube reasons, which is acceptable. State the range of f of x. Okay, well, I can see from the picture that P is the maximum point of this curve. So the maximum value is P's maximum value, which was root 3 over 3. Not P's maximum value, but P's y coordinate, which was root 3 over 3. So the range, I know that the maximum is root 3 over 3. The minimum, oh well, this is rotationally symmetric. So the minimum will be minus root 3 over 3 because it's odd. That makes sense. Give your answer exactly. I did. Now we've got an integration. Using the substitution, u equals that, or otherwise. Look. Never do the otherwise. Never do the otherwise. If they've given you a substitution, use it. Okay, find the exact value of that integral. So let's write down that integral. Are we in focus? Yep. Okay, so u equals, what was it? 2 minus cos x. So du by dx equals sine x. So du equals sine x dx. Okay, that's good. Sine x dx, they're going to go away. Excellent. So this equals, oh, I should do limits. When when x equals pi, u will equal 2 minus cos of pi. Cos of pi is minus 1, so 2 minus minus 1 is 3. When x equals 0, u equals, cos of 0 is 1, 2 minus 1 is 1. Okay, so this equals the integral from 1 to 3 of the sine x dx is going to be replaced by du, and the bottom is u, so that will just equal that. Nice. Okay, let's integrate that. So that's going to be log, oh, sorry, I'm yawning, log of u from 1 to 3. So log 3 minus log 1, which is just log 3, because I can either use the division rule to say that this is log of 3 divided by 1, or I can use the fact that I know that log of 1 is 0. So the area is log 3 units squared. Okay. Now sketch the graph of y equals f of 2x. Okay, wow. Let me draw the original, and then let me draw the f of 2x will be the same but halved. So it'll be stretched parallel to x-axis, scale factor a half. Okay, that's a bit of a weird one to throw in. Okay, this is why. Using your answers from part 3 and 4, write down the exact value of the same integral, but the x has been turned into 2x, and the limits have been shrunk. So basically, well, I really probably should have labelled this point here and here, because, yeah, you know what? Definitely should have labelled that. My bad. So the integral, so basically it wants this pink area here. How does that relate to this area? Okay, let's think. It's been squashed this way by scale factor a half, but it hasn't been squashed this way. So it's got a, I feel like that means the area scale factor is still just going to be a half. It's not going to be a quarter. You know, normally, like, if you have a linear scale factor and then you have an area scale factor, the area scale factor is the linear one squared. But because we only squashed it in one direction, we didn't squash it in the other direction. I think we just need to half it. So I think the area will just be half of log 3. And it does just say write down, so I don't need to do any working out for that. But yeah. Now let's mark it. So, where are we? Substituting minus x is m1. Let's keep those together. Getting minus x is a1. So drawing the picture is b1. Then we've got quotient or product rule, M1, A1 for this expression, E1 for the final answer, M1 for setting the numerator equal to 0, oops, A1 for the answer, M1 for substituting into Y, and A1 for the answer. It says or equivalent, but it must be exact. So obviously 1 over root 3 would be equivalent to that, but it's exact, so that's fine. And then B1 for the range, and it's a follow through, so whatever Y value you got there is what you're going to put in there. And then part 3, M1 for getting to there basically, B1 for the limits, A1 for the answer, then B1 for the picture, and then it doesn't say whether you have to have these labelled. It just says graph showing evidence of stretch scale factor a half in x direction. So the fact that I had both on one picture gives evidence of a half, but if you hadn't drawn the original on the picture, then you would definitely need to put the x coordinates, otherwise, like, how do they know that you've halved it? Then part 5, okay, so you get A1 for half log 3. You do get a method mark, but it says seen or implied. Area is stretched with scale factor half. Now, it does say write down, so it's not expecting you to show any kind of working out anything. The method mark, so I'm going to get the method mark because it's implied by the fact that I got the right answer. But the reason the method mark is there is because if you had got is because let's say you did something stupid, like you wrote that this is equal to, like you wrote log of 3 squared or something like that, which it should actually be log of root 3. But let's say you wrote that it was log of 3 squared or log of 3 over 2 or something like that as your final answer, because you don't know log rules. Then the method mark is there because the fact that you've got a half in there maybe shows that you understand that the area's been halved. It's just there for that reason. And probably because the paper only added up to 71 and they needed an extra mark. I don't know. But yep, that is the end of this test. Thank you very much for watching. I'll be making another paper soon, so make sure you subscribe so that you can watch that when it comes out. Happy revising! Bye!